Why O-shaped Quonset design is the future of family living. An O-shaped Quonset looks like the hardest thing you could attempt with curved steel. 4 sides, 4 corners. A fully enclosed courtyard in the middle. Every instinct says this layout will fight the arch harder than any other. It is actually the easiest one, and the reason is 2,000 years old. Because a courtyard house was never a single connected building. In a traditional Siheyuan, the Chinese 4-sided courtyard home that dates back to the Western Zhou period, the 4 sides are 4 separate structures. The main room, the opposite room, the east chamber, the west chamber. You cross the courtyard to move between them. The courtyard is the corridor, which means the O shape is the only letter layout that asks an arch for no structural connection at all. 2,000 years of extended families proved the plan. The arch just happens to fit it. Start from above, because that is the only angle where the shape explains itself. 4 buildings arranged on the 4 sides of a square. In the middle, an open courtyard entirely enclosed by the structures around it. From the outside, the compound presents mostly closed walls to the road. From inside, every room looks into the same protected, open space. The tradition that perfected this has a phrase for the arrangement: closed outside, open inside. That is the whole design philosophy in 4 words, and it is the opposite of how nearly every American house is organized. A typical suburban home opens outward windows to the street, a yard on all 4 sides, a lawn anybody can see across. A courtyard house turns its back to the world and opens entirely inward. Now, the most common misunderstanding: people hear O-shape and picture a single continuous ring of building, like a donut. That is not what this is, and the difference matters enormously once you start pricing it. It is 4 buildings around a void. In the Chinese Siheyuan, those 4 have names and jobs. The main room positioned on the north side facing south. The opposite room across from it. The east chamber and the west chamber on either side. The main gate sits at the southeastern corner, so you do not walk straight into the courtyard from the street you turn, which buffers the noise and the sightline. 4 structures. 1 shared middle, no hallway anywhere in the plan. Where that arrangement comes from is worth understanding before we talk about steel. The story starts in northern China, and it is considerably older than most people expect. The Siheyuan, the name, means 4-side enclosed courtyard, dates as early as the Western Zhou period, which puts more than 2,000 years of continuous use behind it. In Beijing, the form took hold under the Yuan dynasty, roughly 700 years ago, and the city built them in concentric rings, spreading outward from the imperial palace across the entire center. Here is the part that matters for this video. They were traditionally built and occupied by single extended family units, with many generations living together in the various buildings around the courtyard. Not a house for a couple. Not a house for parents and small children. A house designed from the beginning for grandparents, parents, adult sons, and grandchildren, all on the same square of ground. And the arrangement was organized deliberately. The principal building sat on the north side facing south, and it went to the head of the family because a south-facing room catches the low winter sun when you want heat, and sits shaded by its own overhanging roof in summer when you do not. That was not a status decision dressed up as comfort. It was the best room in a thermal sense, given to the person with first claim on it. The east wing traditionally went to the eldest son. The remaining wings held other family members, kitchens, and storage. Everybody had a building. Everybody shared the middle. That is the plan. Now, why is it a good match for corrugated steel? Because of one thing I mentioned at the start, and now is the time to be precise about it. Those 4 buildings do not touch. There is no hallway connecting the north building to the east chamber. There is no conditioned corridor running around the inside of the courtyard. You step out of one building, cross the open middle, and step into another. The courtyard is not a garden the house happens to wrap around. The courtyard is the circulation system. Now put that next to what a Quonset arch actually is. An arch carries its load down its curve. The corrugated panel is the wall, the roof, and the structure simultaneously, which is why manufacturers restrict door and window openings to the flat end walls, and why cutting into the curved sides requires additional engineering and additional cost. The sides are the building. You do not open them casually. So look at what every other multi-building layout asks of you. An H asks you to join two arches along their sides and run a connector between them. A U asks the same thing at one end. An L asks you to meet two arches at a corner. In each case, you are cutting a hole in the exact surface, holding the roof up twice, usually, plus reinforcement framing, plus an engineer's stamp before your building department will look at the drawings. The O-shape asks for none of it. 4 buildings, each structurally complete, each standing on its own foundation, with its own load path, nothing cut, nothing reinforced, nothing joined. The only thing organizing them into a house is where you put them. The layout that looks the most complicated is the one that requires the least engineering, and it is because the people who invented it never had a way to connect buildings either. 3 things make an arch unusually good in this arrangement, and 1 thing makes it awkward. I want to give you all 4. The first is what happens inside each building. An arch has no interior columns and no load-bearing walls anywhere, so each of your 4 structures arrives as one open span you can divide however you like. In a plan where one building becomes a generation's living quarters and another becomes a kitchen and gathering space, that flexibility is worth a great deal, and it stays flexible because moving a wall later is finish work rather than structural work. The second is phasing, and this is the practical one. Because nothing connects, nothing depends on anything else. You can build the first arch, finish it, live in it, and add the second the following year without touching what you already occupy. That is not a modern compromise either. Larger Sahiwans grew by adding courtyards over time. The form was always incremental. The third is that each building gets its own entrance, which is exactly what a multi-generational arrangement needs, and exactly what an arch provides at both flat ends. Now the awkward part, and it is real. Your openings live in those flat end walls, but in a square courtyard arrangement, the face looking into the courtyard is often the long curved side of the arch, and that side is the structure. So you have a choice to make early. Orient each building so an end wall addresses the courtyard. Add skylights down the arch to bring light in from above. Or do what the original actually did, and stop assuming all 4 buildings must be the same thing. Because in a real Sahiwan, they never were. They never were identical. The main room was the largest and best positioned. The wings were smaller. One building typically absorbed the kitchen and the storage, which kept the heat and the mess out of the sleeping quarters. So, in a modern version, you are not obligated to build 4 matching arches. You might run 2 long ones on the east and west, put a wider arch on the north for the main gathering space, and use something smaller and simpler on the south where the gate is. The plan tolerates that. It always did. Now, what the enclosure actually does for a family. Think about a 4-year-old in that courtyard. There is no road, there is no gate, except the one at the corner, and it is the only way out. A child can be outdoors, alone, without anybody standing over them, and every window in the compound looks at that space. You get natural supervision from 4 directions without anybody supervising. The same geometry works at the other end of life. An aging parent gets genuine outdoor access every day with no traffic, no uneven ground they have not crossed 1,000 times, and no distance from help. Then the separation. 4 buildings means 4 zones with open air between them rather than shared walls. The teenager's music does not travel. The grandparents' early mornings do not wake anybody. There is no hallway where a family collides at 2 in the morning. But everybody crosses the same middle. Every single day, several times a day, going anywhere at all, which is either the great strength of this plan or its central problem, depending entirely on your family. It was never designed for people who wish to avoid each other. Now the part where somebody actually measured it, because a 2,000-year-old plan deserves better than assumptions. Researchers monitored single-story courtyard dwellings in northern China through a summer, recording temperatures in the courtyards and in the rooms around them. The courtyards heated hard. Peak temperatures ran roughly 36 degrees Celsius between 1:30 and 3 in the afternoon, dropping to the mid-20s before dawn, a daily swing of 8 to 12 degrees. The rooms told a completely different story. Indoor peaks stayed below 32, and the daily fluctuation was only 2 to 3.5 degrees. Read those 2 numbers next to each other. The open middle rides the weather. The rooms around it barely move. That is the enclosure doing thermal work. The buildings shade each other. The mass absorbs and releases slowly, and the courtyard acts as a buffer between the outside world and the living space. The same study noted that transitional spaces, the corridors and vestibules between the courtyard and the rooms, delayed heat accumulation further. Now the honest caveat, and it matters if you are building in steel. Those measurements came from buildings with thick masonry walls. Much of that stability was mass, and a corrugated steel arch has almost none. What you inherit from this plan is the geometry, the shading, the buffering, the wind protection. What you do not inherit automatically is the mass, which means if you want the performance the old buildings got, you build for it deliberately. A properly detailed slab, interior mass where the sun lands, full closed cell encapsulation, which on a steel building is not optional anyway. And the old orientation rule still holds. Put your main building on the north side facing south and it catches the low winter sun and sits shaded through summer, exactly as it did 700 years ago. Now the honest problems and courtyard specialists are blunt about the first one. A poorly proportioned courtyard becomes a stagnant hotbox or a cold, damp slot. Those are the 2 failure modes, and they sit on either side of a fairly narrow correct answer. Too small relative to the buildings around it, and you have made a well. Air stops moving. The sun never reaches the floor of it in winter. Damp settles in and does not leave. Too large, and you have not built a courtyard at all. You have built 4 separate houses on a field, with none of the shelter or shading that made the plan work. The instruction from the people who study these buildings is direct. Treat the courtyard as a thermal and drainage problem, not an aesthetic one. Control wind exposure, manage snow and meltwater, and make sure the rooms around it still get enough winter light, because the same enclosure that shades you beautifully in July can leave you in shadow in January. Drainage deserves its own sentence. A fully enclosed courtyard is a basin. Every roof around it sheds inward or outward, and whatever lands in the middle has exactly one way out, the one you engineered. Get that wrong in snow country, and you are not managing a puddle, you are managing a pond with 4 buildings standing in it. Then the arithmetic, which is not gentle. 4 buildings means 4 foundations. 4 sets of end walls, 4 door and window packages, and 4 structures to insulate and condition. This is the most land-hungry and most duplicated layout available. It buys structural simplicity by spending on repetition, and you go outside to cross. Every trip, every season, in whatever the weather is doing. So, does it earn the title? The demand side says yes, and it is measured. 14% of recent American home buyers purchased a multi-generational home. Generation X leads every age group at 19%. And 41% of those buyers named caring for or supporting aging parents as the primary reason, the highest share since the National Association of Realtors began tracking the question in 2015. Families are recombining under one roof. The floor plans available to them are still rectangles with hallways. Meanwhile, the arrangement that solved exactly this problem several generations, one property, separation without estrangement, has been in continuous use for 2,000 years. It is not a new idea, competing for attention. It is the oldest answer we have, and it went out of fashion for reasons that had nothing to do with whether it worked. What is genuinely new is the material. 4 separate buildings used to mean 4 expensive buildings. Steel arch kits change that arithmetic, and the plan that needs no structural connections happens to be the plan the arch can actually deliver. The limits stand where I left them. 4 foundations. The most land you will ever need. A courtyard that has to be proportioned and drained correctly rather than beautifully. And you go outside to cross every day in every weather. Here is what I want you to do before you draw anything. Stake out the 4 corners of your courtyard at full-size actual dimensions on the actual ground with string and stakes. Then stand in the middle of it at 2 in the afternoon and notice where the shade is. Come back at 9 in the morning and notice where the light is. Proportion is the entire game in this layout, and it gets poured into concrete on day 1. Post your courtyard dimensions in the comments. I read them, and I will tell you if the proportion looks right. Next time, how big a courtyard actually needs to be, and the ratio between wall height and open width that separates a microclimate from a hotbox.